Good morning, welcome back. I hope you had a good night. We start today with Ruben, and he's talking about how to, or about the cloud provisioning model in OpenNebula. Thank you.
Okay. So, good morning, everybody. My name is Ruben, and I'm the chief architect of OpenNebula. I'm leading the technical part of the project, and today I'm going to talk about the provisioning model of OpenNebula, the improvements we've been making during the last year, and hopefully trying to show you how we evolve this model to accommodate different use cases, right? So, let me first talk about some considerations when you want to build a multi-tenant infrastructure. First, about the physical resources you have in your data center. From the point of view of OpenNebula, we wanted to provide the tools to establish the policies that allow you to serve physical resources between your users. So in this sense, OpenNebula provides you with the functionality and features to establish these policies, right? The second thing that's important when you want to deploy or create a multi-tenant infrastructure is to put in place proper isolation mechanisms for your users. So the idea is that users cannot interfere with the other users of your cloud, and not only in terms of security, but also in terms of access control to the resources that they are using in the cloud. And that's the third part. You want or you need to control and limit the usage of your users, right? So these 3 points is the when you look at the physical infrastructure, the things that you will need from your cloud orchestration management tool, right? But in terms of virtual resources, I'm talking now about the virtual machines, disk images, or virtual networks. You probably want to establish or put in place proper self-provision mechanisms for your users. So you want to let your users use your cloud as autonomous as possible, right? In this sense, we also face that we have very different requirements. I'm going to talk about this later, but there are like 2 different use cases and 2 different provisioning models that are valid when you go to cloud. We've heard of this in some of the talks yesterday, and OpenNebula tries to implement both, so you can choose whatever is better for your cloud, right? So let's start about the features we have or we are developing in terms of the physical resources itself, right? So the first abstractions we implemented to reach the goal of having a multi-tenant infrastructure is the cluster. A cluster is a logical group of hypervisors, data stores, and virtual networks. This logical means that you don't have, or they don't have to be in the same rack or in the same physical location. You group them logical for basically 2 different reasons. The first one is placement policies. If you have clusters, you can establish allocation policies in terms that a given set of virtual machines are going only to run in a given set of hypervisors, or are they going, or they can only use a given set of virtual networks, or they can use only a given set of images for the virtual disk, right? And the other and the other thing that or the other reason you want to use clusters for is the access control. You can devise allocation or access control rules, so users can only use, see, or interact with a subset of your resources of the cloud. So those 2 things, having placement policies, a way you can put or allocate VMs to a given set of resources, and access control policies, a way so you can allocate users to a given set of resources, are the main reasons for using clusters. That's okay, but we have received quite a few requests in terms of clusters, because now clusters or resources can be assigned only to one cluster. So this is a limitation in terms that, for example, it's not straightforward to serve resources, or, for example, all the hypervisors across all the clusters. So in the next release, we are we want to implement both this concept, so you can assign the same resource, for example, a hypervisor, to different clusters. So that can be served across clusters, and it should be easier to establish resource sharing rules. What we are seeing right now with our model is that sometimes the infrastructure evolves to isolated silos of resources, so it's not really easy to share the infrastructure across the users. So that's for the next release, right? Okay, so once we have the clusters as an abstraction to group physical resources, we then have its relations with user groups, right? The third reason to use cluster is that they can be used as a resource provider, a way to provide resources to a group of users. So when you define a cluster, it's not only for placement reasons, but only you can think of it like a container for your users. So when you define a user group, you can assign one or more clusters from one or more zones, right? So in this sense, a cluster can be also seen as a resource provider. How do you, two different user groups can serve a cluster. So you have several tools in your hand to limit or control usage. You have quotas, so you can assign a fraction of the cluster to a given group and not to the other. And also, when you assign a resource provider to a user, you are giving to users the ability to self-provision themselves with the infrastructure you set for them. For example, you have the hypervisors in the cluster, so users can allocate VMs in the hypervisors. You assign data stores to the cluster, so users can save VMs in those data stores, or can create disk images in those data stores. And with the last release, where we implemented security groups, users can even self-provision virtual networks, because you assign a network to the cluster, and the users can reserve an address space from the network that it's implemented as another virtual network, and they have their own virtual network. So self-provisioning, when you establish a resource provider for the group of users, means provisioning across all the three types of resources. In terms of, I can allocate VMs on the hosts, I can allocate disk images on the data stores, and I can allocate my virtual networks on the virtual network I assign to the cluster. So in the also, when we receive feedback about this, we receive quite a few times the ability to somehow show the users how many resources they've been consuming in infrastructure. Right now we have the accounting, which is a way to have a picture or a view of the resources consumed by a user. But usually that's not enough. What we've been requested several times is that the system administrators, the managers of the infrastructure, wants to provide figures about the usage for the users. So we implemented what we call showback in the next release. This is already in the master branch, so it's if you want to try it, it's already there. And the idea is that you are the system administrator, you prepare the virtual machine, and you assign a cost to the virtual machine in terms of the cost of the hours of CPU and the cost of memory. With these two costs, users can have a summary of the usage they've been done during the last months in terms of that abstract cost. So, for example, if you have measured how much does it cost the CPU hour in your data center or in a given cluster, so you assign that to a template, and the users say, okay, that last month I spent like 3 or 10 units of cost in the cloud. Okay, on next one. So we have clusters, we have the group of users groups, and we have the ability of assigning clusters to a group. These two concepts were what we call a virtual data center. You have one or more clusters in one or more zones, and a group of users assigned to them, and that's what we call a virtual data center. A virtual data center also have a special user, what we call the vDC admin, which is the administrator of the virtual data center, but it only manages the user, the logical part of the data center. The infrastructure part of the data center, the cluster, it's managed by the infrastructure manager, but the users, the quota usage for the users of the group is managed by the virtual data center admin. So that's a way to delegate the users management part of the infrastructure to the vDC admin, and keep the infrastructure management to the sysadmins, right? We develop a special view for these users that we call it Cloud View. It's a very easy interface, very easy to use, and very straightforward for end users. So I'm going to show you in a minute, in case you didn't see it before. And the other powerful concept of this tool is that you can assign clusters from different zones. So as you probably know, OpenNebula can work in a federated way with different OpenNebulas running in different data centers. So the virtual data center, the vDC, can be composed of a group, a user group, and clusters from different data centers in different locations. They can even include resources from a hybrid cloud. So your virtual data center can be your users, a cluster from a data center A, data center B, and a set of zones in Amazon EC2, for example. Okay, so you have your cloud, you have prepared your clusters, you have your groups, you even can have vDC admins for your groups. How do you bootstrap the cloud? How do you prepare the content of the cloud? We think that there are three, this can be done in 3 steps. The first thing is that you have to prepare the disk images for the virtual machines. Usually, this can be our operating system vanilla installations, like raw Ubuntu, CentOS, Windows, or whatever, that can be used for directly consumed by the users, or pre-built appliances with additional software like, I don't know, a web server, a content management system, a Java development platform, a unit testing facility, or a continuous integration facility, whatever. You have an appliance with this operating system, the software that your users want to consume, right? We also have the ability to upload this content from the users, so the users can prepare the images and upload it through Sandstorm, for example. But we think that our experience is that in real life, this is not very convenient, because you can have clusters with specific configurations, or you can have requirements for your hypervisors that your users cannot deal with, or they cannot reproduce in their laptop when they're preparing the images. So It's better for you to prepare base images, give it them to the users. The users can install there more things or customize them as they want, and then they can save the changes. One important thing when you're preparing the images is that probably you will like to leverage context. The contextualization process of OpenNebula, as you probably know, is the ability to inject or pass information at boot time so the virtual machine can configure itself. Usually we put there SSH keys, or you can put there Puppet or Chef receipts, or the information to connect to an auto configuration tool to install more things, or whatever. When we designed the Cloud View tool, we also had the requirements for, okay, if this is going to be deployed and instantiated by the users a lot of times, probably I want the users to give that input at somehow. So in the last release, we also added the ability to include user inputs. User inputs are special fields that are filled by the user when the virtual machine is deployed. So you can, for example, ask the user, okay, I'm going to deploy a MySQL database, so please, when you're going to deploy the VM, give me the password for the root user of the administrator of the MySQL database. So the user just input that field when the VM is going to be deployed. That is added to the context, and you get the context in the virtual machine, or you have prepared the virtual machine in the contextualization phase to get that password and put it in the MySQL database, for example, right? Okay, so once you have prepared and you have your disk images ready, the next step is prepare the connectivity for your virtual machines. You have virtual networks defined in infrastructure. Here you can either predefine network connections, so when you define the virtual machine, you have wired connections to the virtual network, so you can just leave it there, and when the user instantiates the virtual machine, he can pick which virtual networks are going to use. Which one are exposed to the user? The ones that are or belong to the resource providers you have defined for them, right? Regarding networking, in the next release, we have implemented also security groups, which is basically the same functionality you have in Amazon EC2, quite a little bit extended. So in the next release, you are going to be able to define basically firewalling rules for your VMs. These rules involves inbound traffic. You can define rules applying to any address, a subset or address, and so on. Different protocols, port ranges, and so on. Also, we've included there the virtual network semantics. So you, for example, can establish a rule that applies to all the VMs that are running in a given virtual network, instead of referring to them based on the IPv4 or IPv6 addresses, right? All these virtual groups can be, security groups can be defined for the virtual networks, and users can add more security groups to the VMs, right? So when you have the disk, you have the networks, then you prepare the VM template. So what you include in a VM template? Usually you include hardware presets for the virtual machines, like specific attributes for the images. For example, you have prepared cookout2 images, so that can be included in the template. Also, you can add hypervisor settings that are specific for your deployment using the appropriate field in the VM template, and you can predefine placement policies for the VM. For example, if you want a given template to be allocated always in a system data store that is going to be redundant in another location, for example, you can do that when you define the VM template for the users. And now you can even define a cost for the virtual machine, right? So when you pick disk and virtual networks, all of that determines which cluster or which resource provider is going to be used to run the virtual machine, right? Okay, before going here, let me show you how all the things that we've been discussing to here works, right? So, for example, this is a very little cloud with a couple of hosts. So, clusters. Here I have a couple of clusters defined, which includes hosts and data stores. When you create a cluster, you can use it's as easy as define a name for the cluster, and then you have here all the physical resources that you can assign to the cluster. So as you see, this can be KVM hypervisors, but you can also put in a cluster an Amazon EC2 instance, or a host that represents the whole Amazon EC2, right? You can assign one or more networks to the cluster, and you can assign one or more data stores to the cluster, right? When you take a look to the data stores, you can even reserve a given amount of CPU of the cluster, so you don't exceed that amount in the host, and you can monitor the resources assigned to the cluster, right? So when you define a group, like this one, you establish some presets for the group, like for example, which Sandstorm views are going to be available for that group, which is the default Sandstorm view for the group. You define which resource providers are going to be allowed or are going to be used for this group. This resource provider can be here in this example. I just have one zone, but if you have several zones, you can pick resource provider for several zones. You can assign all the resources of a given zone, or you can select a cluster or a couple of them to support the group, right? Then you can create a vDC admin, which is the user that is going to manage the user space of the virtual data center, and you can define a specific rules for the group. For example, I don't want this group to create images, or I don't want this group to create virtual networks or documents if they are not going to use the OneFlow tool, for example, right? Once you have a group, you can take a look to the basic information. You can set quotas for them in terms of, for example, you can define how many virtual machines the group is allowed to deploy, the overall memory the group can consume in the virtual machines, how many CPU can be consumed by the group, how many storage can be used in volatile disk, and you can even put quotas for specific images. For example, if you don't want a given image to be used more than a given number of times by a group, for example, because you have a license in the image and you just want 5 instances of that image, you can set it here. Or the number of network leases. You, for example, want to limit the number of IPs that a group can use, you can set it here. Also, you can set quotas for data stores, the amount of disk space you allow to the group to use of a given data store, right? Then you can update the resource provider of the group. You can get basic accounting information of the group, and this is the well, I show you this in a moment. The same thing is for the users. Here we have a user in the group, and this special user, which is the group admin. So how is this really implemented? When you define this resource provider access, or you define a virtual data center admin, what you are doing is, or what OpenNebula is doing, is setting up a set of ACLs for you. So for example, we have an ACL that says that the big data group can access all the resources, host virtual networks and data stores in cluster 102, for example. And we say that the BD admin user can manage users of group big data. So this means that this BDC admin can remove, add, or create users for you. As you see, if you don't, or you need to tune this default behavior, you can always do it by updating the ACL rules that is created, automatically created by OpenNebula when you define the group, right? And templates. How do you define a template? There are quite a bit options here. The important ones is that when you prepare a template, you put a name to it, like a test Linux installation. You can have a description here for your users. This is going to be later shown to them when they pick. You can even put a logo to the VM. You can predefine the capacity of the VM in terms of the memory and CPU. You can assign a cost. For example, the memory hour cost for the gigabyte, it's 1 unit, and the CPU hour, it's 0.5 units. These are abstract units that has to be translated to real cost in your cloud, right? Storage, you can pick one of the disks that you prepare for the users, and you can pick one or more connections for this VM to the networks that have been defined. For example, one connection to one network, another to the other one. Then you define architecture, boot order. In the hypervisors that support that, you define kernel, RAM disk, specific features like Hyper-V, the ACPI, and that kind of things. You can define a vDC or a SPICE access to the VM. So you presets all these sets for the users. So there are two options. I'm going to talk about this later, right? The other important thing is the context. What is going to be injected in the VM once it boots? Here you can add the SSH contextualization. So if there is any SSH key defined for the user, is going to be injected in the context information. You can add files to there, and this is the new user input things. For example, if you say, I want you to add the MySQL password, this is of type password, and here you can put a description for it. When the user starts this VM, it's going to be asked for a MySQL password. So if you have prepared the disk to have a MySQL installation, and you have prepared the VM to set the password, getting the password from the context when it boot up, that's going to happen. So you can automate all the process to provision a VM for your users, right? And as I said, you can predefine policies for the VM. So you want a set of VMs to run in a given host of the clusters. You can do it here, or you can define a policy, like, for example, I want to apply a packaging policy in this cluster. This means that I'm going to try to pack all the VMs in the hypervisors for a given resource provider, or the opposite. I can pick a stripping policy for this template, so I'm going to try to spread all the VMs in the hypervisors. You can predefine that for your users. And finally, you can even add a hybrid version of the template, right? So far, this can be too complicated, right? If you have to define all these things, at least you have to be trained for that, and you have to have the knowledge of doing that, right? So that's the other thing that we've been improving in OpenNebula during the last year. When you think about this, this is classical now. There are like two models. We have the cattle model and the pet model. Cattle are things that can be easily disposed. You don't love them. You don't keep them in your home. So if you lost them, nobody's going to worry. So when you are in the upper part of the arrow, you have to be prepared for failure. You start your VM, the VM can fail. Persistency of the data has to be handled elsewhere, and you have to be aware of that. Usually, in that model, what we have seen is that users are exposed to very simple interfaces. The set of API actions or the interface actions that can be performed over the VM are very simple. Just boot the VM, shut down the VM or power off it, or save this, and that's it. Nothing more. And they don't have a very rich view of the VM, as I saw you previously. They don't know all the storage networking connections, if it's a cookout to image back in the VM, and so on, right? Usually these VMs have short life cycles. So you go to your cloud, start a VM, make your test, develop something, and when you finish, you're done, and you shut down the VM. Usually you see this this use case is associated to the cloud paradigm, right? So this is a cloud-like provisioning model. And when you go to Amazon EC2, for example, that's the kind of behavior you're going to expect, right? So at the other end, top down in that arrow, you have your pets. Pets are special things. You love them. You keep it at home. You put them a name, and you take care of them. So it's the same with VMs. When you have a server which is the web server of your company, you don't want the web server to power off or fail. You have a name for that server. You take care of that server. You need probably to establish high availability backup policies, something you are not seeing for the other VMs. Even you need richer interfaces, because, for example, if you have to maintain a given hypervisor, you want to live migrate your web server of your company to maintain the original hypervisor, right? And usually, those are for long-lasting life cycles. So those are virtual machines that are boot, that you upgrade, that you apply security patches. That's virtual machines with long life cycles. So that kind of interaction is what you expect for tools like vSphere, right? If you have experience with VMware products, if you set up a vSphere cluster, that kind of rich functionality, that kind of interaction is what you get from them, right? So where are we? We are somewhere in between, right? So with OpenNebula, we wanted you to give you the flexibility of vSphere if you want to deal with your cluster, but the ability to expose something as simple as Amazon EC2 to your users. So in a way that you can have the best of both worlds, right? So in OpenNebula, how we deal with cuddles? The idea is that you prepare your virtual machines, thinking that this is going to be installed once, but it's going to be instantiated many times, right? But for your users. Here you can leverage context, because as you are going to instantiate the same thing multiple times, that same thing is going to be different or a little bit different for different users. So context is a powerful tool to specialize this base installations, right? As I said, for Catalyst, you don't need very rich set of operations, right? So we define or designed a very simple graphical user interface, which is CloudView, for them, right? But sometimes you have to take care of the of those cables, right? You have to sometimes you want to persist some of the changes. Sometimes the users take your base operating system installations and install something, and they want that to persist. Right now in OpenNebula we have that, as I will going to show you in a minute, but this support is somehow not complete. So for the next release, we want to implement or improve the persistency operations of the VMs in two ways. The first one is the it should be easier to clone VMs. So once you have a VM up running and in a state that you like, it should be easy to say, okay, I want to save this VM for later use. Right now you can go, snapshot the disk and clone the templates, readjust things. So it's it takes you a lot of clicks and editing a couple of times the VM template. So we want to simplify the process. So if you have a VM with several disks, just clone the VM as a template, and you have a new template with a new set of disks that can be instantiated for the user, right, or by the user. And sometimes you want this. We receive a couple of requests also to make that process before deploying the VM. So when you start a VM and you have a disk that is not persistent and is going to be lost, probably you want to clone the disk before deploying and make the new disk persistent and start the VM from it. So that's something that you can do right now, but it again takes you a couple of clicks. So we want also to simplify that process so it's easier for the users. So what's the interface like, just in case you didn't have the opportunity to take a look at it? So I'm logging like a user for a regular user, right? A vDC user, if you like, if you will. So you have a very simple dashboard with the number of running VMs right now, the number of virtual machines you executed, and you can take a look to the virtual machines you have running. That right now I have 2. The virtual machines that you saved for based on one of the virtual machines prepared by the admins, and you have modified too. If you have flows, they should be there, and a basic configuration for the user. So what happens when you start a new virtual machine? So you start with a dialog as simple as this one. Just in one click, you can fire a new virtual machine. Just put here name, like this one. You can pick one of the templates that has been prepared by the cloud administrator. You can pick one of the templates that has been prepared by the vDC admin, or one of the templates that you've saved from your previous work, right? So when you pick one of these, you can just go and start it. But you can change the capacity if you will. For example, this one has a 1 CPU and 128 megabytes as a preset, and it has an associated cost of 128.5 unit of cost per hour, right? But if you as an administrator can define different sizes, so probably I want to increase the capacity or whatever, right? As we saw previously, you can predefine network connections, but the user can update that. So this cluster or this user have access to the public network and the private network. So he can update the connection, so you can prepare plain templates with no networking connection, and the user can pick the one he want to bind the VM to, right? And finally, here we have the custom attributes. Those are the user inputs we've seen previously, the input you request for the user to start the VM. For example, in this case, is the host name. If you have a hook and you want to update the PTR records in your DNS server, you can ask the user for that entry, for example. Okay, something like that, right? So once you start the virtual machine, here you have also a reduced set of information for the virtual machine. You have here some statistics about the CPU, memory, network usage. Here you have the template name, a summary of the capacity, the IP address assigned to the virtual machine. Once the virtual machine is running, you can do a lot of things with it. You can reboot the virtual machine. Maybe you want to power off it or dispose it. That's it. So simple, so easy. Maybe you can, or you would like to have access to the virtual machine. Here you cannot see it, but if you take a look to the host name, I don't know, it's going to work the thumb. If you take a look to the, no, it doesn't work. Well, oh yeah. Here you can see my server, which is the my server input that I use when I define the virtual machine. So I have this virtual machine prepared to get that input and update the host name of the VM, right? So, this is a preview of we've done about the softback. So this user can get the softback for different months. And for example, here it said that in December, I spent 473 units of cost in the cloud. If I go to this month, here I have a summary of which VMs produce this cost. So for example, here I say that I spend 469 units of cost in this VM and 4 units of cost in this VM. This is something that's going to be ready for the next release. So I hope you, of course, if you don't have cost associated to the templates when you upgrade your OpenNebula installations, you are not going to see the cost, but it's still useful. For example, here I have the softback for a previous month without cost, and you don't have the cost, but you have a summary of the virtual machines that were used during that month and the number of hours associated to each of the VMs. So that's still useful, even though you don't have cost for the templates, right? Okay, and just to finish, we also have the Samsung view that I'm sure that all of you are aware of, and here you have all the details of the VMs. You can attach disk, attach NIC interfaces. You can live migrate. You can stop, resume. You can stop in the data store and move out away from a hypervisor and so on. And this is what you would expect to take care of your pets, right? So for the next release, we want to do a couple of things to improve this. The first one is cold attach of disk and network interfaces. Right now, the VM has to be running to do that. And in fact, there is no problem to do that when the VM is power off. So that's something we want to fix. And there is also a request we've received plenty of times, is the ability of move a VM across system data stores. When a VM is running a system data store in a given host, probably you want to maintain the data store. For example, you want to upgrade the NetApp storage server, which is backing up the data store. So you want to move the VM from a data store to another one. That's something we want to implement for the next release, because it's typical to take care of your pets, right? So that's it. Thank you very much for coming, especially after late night last night. And thank you very much for your attention.
Okay. Any questions?
No.
No one? Okay. Question from me. When is the next release?
That's a good one. Yeah. We want to make probably maintenance release, not I would say a quick one, right? Probably around the end of the year or beginning of the next year. That's going to be 4.10.2, I think. And for 4.12, it depends how many things we want to put there. Those I saw you are we want to make those happen. There are a lot of things already done. We have the security groups, we have the SOBAC ready. All of that is already implemented, and we want to probably or wait a little bit for pack more features, or just release what we have right now. That's something that probably we have to decide. We've been doing a quite aggressive release cycle that probably we can talk about, because we have like 4 or 5 releases each year. And I don't know if when I went to the talks, a lot of people were in 4.2, 4.6, 4.8, which is a couple of releases behind what we are doing. So that makes us wondering if we're being too aggressive releasing OpenNebula, and probably it's better to slow down a little bit. I don't know. Probably it's something that we can discuss we have an open discussion session that maybe it's a topic for discussion. I don't know.
Okay. Any more questions? No. Thank you, Ruben.
Thank you.